Good morning, everyone. Thank you for attending this session. So today we are hosting a special session with Nikhil Malhotra, Chief Innovation Officer at Tech Mahindra. Uh, uh, they have just 2 days back launched Project Indus, which is an Indic LLM model developed solely in India by the Tech Mahindra team. And there are some many firsts which their team has incorporated in building this model. So I hand over to Nikhil to walk us through what was the thinking behind the Indus project and what you have been able to achieve so far, and what your goal would be, eventual goal would be, and how can the community here join hands together and uh, build this forward.
No, thank you so
So
much.
over to you, Nikhil.
No, thank you. I think thank you for giving us this opportunity. I know I've been missing these calls, but good to be on this because of my travels. I think background for me, it's almost been 2.5 decades for me in this IT industry. But I started off as a researcher with the IBM research group and was, in part of the team that was building the earlier Watson system. So language was always embedded. So, my journey now and what I'm going to explain to you is not just Indus, but things that we're doing across the world, things that you would see a typical R&D organization does. And the reason for building this kind of R&D organization within an IT services is how do you pick up the Indian R&D stack? And that was the main reason that I came back from US, joined the company and started this process. So while I'll talk about Indus, I'll also talk about a large part of what we have been doing, in general across the world as well. So let me know when you can see the screen and I can start.
Yes, visible. Yeah.
Okay, brilliant. So the R&D division of Tech Mahindra is also called Makers Lab. And if you go and search on Google, you will find hundreds of things that Makers Lab have done over a period of time. We have a kind of vision for enterprises. And I think this vision is largely because of the things that we are seeing across the world, right? So for example, most of the enterprises and things that you would see from a government perspective or also from a corporate perspective is that most of these companies and folks have actually transformed themselves into digital enterprise, right? So this has been a journey which happened in 21. I think what we are trying to do from Tech Mahindra perspective or also from an core R&D perspective is to make sure that how do we actually get some of our customers and people who connect to us into a much more cognitive enterprise. And the difference between the two is largely what I've written, which is you make sure that these are AI infused, but you also ensure certain other things like digital presence and so on and so forth. Where we pave the way for enterprises to become more quantum, right? So 2027 onwards, in fact, next year only, we will see very deep capabilities and very, large number of green offshoots happening on the quantum, largely on the security part. But 2027 onwards are our hope, and this is what we predict, is that you would also see quantum machine learning occurring into lives. And this is something which is happening across the world as well. Now, what does Makers Lab do? Makers Lab is a World Economic Forum recognized open R&D ecosystem. And we've done many firsts, over the past 10 years. In fact, some of this is actually shown in front of you. While each one of you faced that heat of COVID, there was a COVID vaccine. There was also a lot of research that was done on the therapeutic system. And I'm very proud to say that Makers Lab is responsible for finding out the therapeutic molecule against COVID. This took us about 1.5 years of research. And this includes Gen AI, genetic algorithms, even before Gen AI became a kind of topic of discussion last year. And this therapeutic molecule went through various stages in terms of what we have done. So we looked at 8,000 based FDA drugs. We actually catapulted them using molecular docking and computational drug discovery mechanisms to bring them down to 17. These 17 were then Petri dish tested in vitro, where with our partners called Region Biosciences, which actually came down to 3. And these 3 were then tested on a 3D printed biolung outside the human body, where we actually made sure that these molecules don't actually cause thrombosis or clots, as you may call it, in the human body. So that is the reason, and we've been actually given loads of awards. You can read about it in terms of what we've done on the therapeutics. Obviously, we are an IT services company, so we cannot take it into a medicine format. But we showed the world how collaborative ecosystem of innovation really works well in a country and in terms of what we are doing from an IT services standpoint. If you bank with a public service bank called Union Bank of India, that bank is the first bank in India which has gone onto metaverse. That is also done by Makers Lab, Tech Mahindra in 2021. You can still go on to unionbankofindia.com, take your phone number, log in, and you will enter into the Metaverse Lounge. This was also the era when consumer metaverse became pretty popular, and there was a Me Too kind of movement. Everybody wanted to get onto the metaverse as well. But this bank had a very specific purpose. The purpose was, how do you attract millennials? How do you save the retail and non-retail space? And how do you really give training to some of their own folks in terms of banking that you do? So this bank is live. You can you can look at your account balance. Of course, you can't transact money because that is not allowed by RBI of the country. But you do all sorts of other things on the banking system as well. So what we have seen over the past 1.5 years, we have almost seen a blip or increase of about 120,000 people joining this bank, largely because of the metaverse, which was really the ROI that we got. The entire state of Tamil Nadu, and state health is a state subject in India. The entire state of Tamil Nadu has a public health registry record, which we built with Google about a couple of years back during COVID. And obviously, COVID was the trigger for this, figuring out in anonymous mode what people or what kind of diseases people have, or what kind of morbidity we have, where God willing, God forbid, if this condition arises again, we would have a good amount of registry of people in terms of what they are doing. And the first quantum key distribution use case for quantum security was actually done by Makers Lab in 2018, way before some of the people entered into quantum security. Now, while the left side is more of marketing, the right side is something that you need to understand and see. Makers Lab is also considered a kind of collaborative. It's a case study for an open R&D ecosystem in the World Economic Forum. You can read about those reports. There is also statements given by none other than Klaus Schwab, who actually considers this. And this has largely been the work that we've done over the last 10 years with loads of stakeholders, right? We've done with government, with corporate, even with, even with academia as well. And there's a large academic connection that we have in terms of what we do for research, both fundamental and translational, at a very edge-based facet. If you come from a farming community or you have connections, 140 million farmers of India typically use an app which is also built by Makers Lab. It's called Atmanirbhar Krishi app. And that app actually gives you a large amount of information on weather, on precipitation prediction, on soil health card data, and so on and so forth. And we've connected and aggregated data from Indian Space Research Organization and many others. And this is also part of the PSA work that we did, which is the Principal Scientific Advisors work for India. There are many firsts. Because of lack of a paucity of time, I can tell you that we are the only ones in the world who also have an algorithm about the old Indian Panchang. And you normally see Panchang or hear Panchang in your houses. It's an Indian calendar, but we are the first ones who actually took Panchang and we actually converted it into a kind of ecosystem for, a kind of algorithm. And we actually tested across large parts of the world. And we proved, and there's a paper, if you read about it, that over long periods of time, if you want to predict precipitation, Panchang and the measures of Panchang actually are 10 to 15% more accurate than a meteorological department sector. So that's also another thing that we did. Now, we have a POV on Gen AI. I don't want to go through all of this, but I think we want to make sure that we globalize innovation. And that's why Makers Lab, the mothership is in Pune, but it sits across the world. And obviously, we innovate at speed with some of our partners like IBM. The recent story of Indus was also with Dell and Intel. We're doing loads of work with NVIDIA and AMD, and there's a lot of research that we do, which I'll talk about it at scale in terms of how do we make things sustainable. Largely, why we do this is because AI is unsustainable. And if anybody tries to tell you that AI will be part of the sustainable journey, and while using AI, you become sustainable, that person doesn't know AI. And there's a report on McKinsey on the right-hand side, where we see whatever models that you train and you build, these models actually create 57 times more carbon dioxide than typical air travel that was considered to be the worst facet of environment or climate impact that you would do. So most of my work and my team's work is actually making sure that we research and make sure that these models are sustainable. These models are both compute and carbon friendly, so that when we actually apply them for our people, right? It's not about large language models. It's not about making big. It's also about precision. And it's also about making things smaller. And large part of research that we do is also making sure that this happens. And this is why, a lot of work that we do around it. Quantum takes its facet over there. because quantum is a sustainable format of technology. So we are also researching on some of those aspects as well. Okay. So what's the LLM story? I think everybody wants to understand about Indus. Indus actually came to us as a challenge. About last year, Sam Altman was here in India, and Sam Altman probably in some format of the conversation that happened with Sam said that it is very difficult for India to actually make a large language model from grounds up because it will take about $100 million odd in terms of what we're doing. I think our ex-CEO CP wrote a tweet which says from one CEO to another, challenge accepted. And this is where the challenge came to us. And I think it was about 11:30 p.m. I think CP has also spoken to media in a big way. At 11:30 p.m. he called me and we decided this. And within the next 6 hours or so, we had a plan ready in terms of what we wanted to do. Now, was it language that we were considering? I think we were considering not just the mother tongues, right? So, for example, the condition about India is a land of about 24 mother tongues and 1645 dialects officially. Whereas unofficially, this country speaks 19,200 dialects. And those dialects are spoken in various formats, in various diversities. Every 50 kilometers, you will see the dialect or the way of speaking changes, in terms of what people do. Also, these dialects, some of these dialects are getting extinct, right? They're already under the endangered list. So we knew from the very start that if we had to build something like this, we will have to consider not just the mother tongue, but we'll also have to consider the dialects as well. So we went around saying, look, Hindi is the most widely spoken language. It is spoken by 650 million people across the world, much larger than people who consider English as their first language or native language. So we thought that we will build the model from grounds up in Hindi itself and some of the dialects that we do. What about the tokens then? I think when I started working on this about last year, and Bhashani was also working at the same regards over there, we found that the number of tokens that anybody could use from the internet were just about 2.8 billion tokens. And for those of you, obviously, who understand tokens, these are subwords or characterization of words that you want to do. Now, 2.8 billion tokens do not create any kind of large language model because we don't have a lot of language over there. Number one. Number two, for some of the things that ChatGPT was doing, which was around 175 billion parameters or 8 billion parameters, they almost use about trillion tokens, right? So 300 trillion, 100 trillion tokens. So we were not there. So Hindi and some of the languages were underrepresented. Hindi, you may find still some tokens like 2.8 billion, but for dialects, you would never find these tokens in the digital world. So how do you collect that, right? And how do you really look at those dialects as well? So we actually not only developed this model, but we also collected a large amount of data for these dialects. And these dialects are very, very different. I'll show you the number of dialects that are there. But first and foremost, our part was how do you collect dialect data? Second was how do you curate and train and cure some of this data, because these data will also carry a lot of biases. And third, obviously, was the part of training. Well, God willing, we actually managed to do this in the 6 to 7 months that we have actually been on the journey. And we today have a 1.2 billion parameter trained model, which is single shot fine tuned, of course, and it has got 22 billion tokens. And we actually took only about $250,000 to $300,000 to make it. Now, this is a big shift from $100 million or $10 million in terms of what we do. What we also did is we are very thankful to CDAC because we utilized CDAC GPUs. These were large 40 GB GPU machines, 48 of them, which we trained them for about 7 to 10 days continuously to make sure that our models worked well. But this model is unique because the decoder architecture from the tokenizer up till the inference is actually built grounds up. There's no English. It's got no spurious token. It's got only Hindi and its dialects tokens over there. And when we actually tested the model has a loss of about 2.3 to 2.4. If you compare this to the original model of GPT-2, which was roughly of the same type of about 235 million to 400 million tokens or parameters, that had a loss of about 2.6 to 2.8. So we managed to reduce the loss as well. And then obviously when we were doing this, a lot of our partners came into fore. Dell, Intel came in. So this model is also now LLM professionally tuned or performance tuned on Intel Xeon servers. These are Xeon 5th generation servers that we are actually using to actually fine tune or do a performance tuning of these LLMs. Now, Hindi dialects, as you can see on the screen, some of this you would know. Some of this is available and you know that Hindi is spoken in this way. The others in 37 different ways may be very, very new for you. Dialects like Khorta, dialects like Panchpargania, dialects like Angika and Nagpuri are spoken by very few people. And so we had to collect that. We had to ensure that some format of that dialect goes in. We still lack a lot of dialects. We still don't have those dialect structures over there. But some part of those dialects actually went in along with Hindi. So what we did was we did a kind of collection drive. And we did kind of a Bhashadan system. Of course, we were inspired from Bhashani. Bhashani also does Bhashadan. But we got inspired and we made our own Bhashadan portal. Our teams went like a Buddhist mission across the Hindi heartland, whether it was, whether it was somebody speaking Hyderabadi Dakhni as well in Hyderabad to Madhya Pradesh to Ranchi to Rajasthan. We connected with people. We actually connected with professors. We actually asked them to speak in their own language. We collected that kind of data and we actually poured it back into the system. But there was also a large amount of data that was also available from various other sources, which had to be cleaned, which had to be bias tuned. And we found that all of this data also had loads of biases, right? So biases in terms of, there were 12 different biases that we found. They were not just ethical, but also regional bias, political bias, the bias against disability, and so on and so forth. So a large part of our work also went in removing these biases. One of the ways to do this was also use human annotation systems. But then we suddenly realized that if we look at human annotation, this will take a lot of time for us. So we actually developed a kind of machine learning system which automatically cures the data of about 65 to 70% biases on its own. And it actually starts working from there. And then the human can actually look in. We are now working on something called a Garuda LLM, which is actually being worked with NVIDIA and some of our partners in Indonesia. This is a model that we are now building on Bahasa. This is not a 4.8. This is an old PPT, but this has now become a kind of 8 billion parameter model today. And the first and the foremost use case over there, it's actually based like Indus, but it's actually now going live in the next month for citizen services in Indonesia. And Indonesia is pouring huge amounts of effort and money in terms of making Gen AI possible. Question is, when we make these LLMs, right? Somebody says, what's the big picture about these LLMs, right? So what do you do when you start making LLMs? I think everywhere that you go, and we're doing loads of these large language models or small language models, as you may call it. They are happening across the world in terms of logistics. They're happening in terms of retail, healthcare. Everybody wants to build a kind of verticalized LLM structure. And we found that there is a way in which companies can also monetize on this. I think this is one of those cases. You may find it a little bit more, verbose over here. But the idea behind all of this is that if you have the compute infrastructure, which you're seeing some of the companies taking across. For example, Reliance Jio has also gotten a lot of NVIDIA servers that they are now placing in. There's a huge way in which you can create a kind of marketplace over LLM, where proprietary models, where customized models, advisory and ideation and golden use cases can actually be run, and they can be given on a subscription basis. So there's a monetization facet as well in terms of what we are trying to do. But there's also a kind of work that we did for India in terms of the Indus model. Based on what we did, we thought we'll actually create a kind of architecture for everyone. And this architecture is generic, which can be used for almost every enterprises, government and sectors, and so on and so forth. So we were largely influenced by the Three Body Problem series. If you have not seen it, go ahead on Netflix and you will see that this is a fantastic sci-fi movie, but we were impressed by what Three Body Problem is. So for LLMs and for this work and this generation of or this format of Gen AI, we thought that the three body problem that we are trying to solve is what would be the case, right? So before I go into proprietary LLM and SLM, I just need to tell you that this is no longer the war of the clouds now that you are actually facing. These are the wars of the semiconductor. So anybody and everybody who understands the semiconductor and the chip today has a larger role and a larger goal to play in terms of how these models could be deployed. There are two reasons. A, when you talk about cloud, you have loads amount of lock-in period. And as a result of that, companies and organizations spend a lot of money in that lock-in. B, people also want to have data sovereignty and not send data onto the cloud, even though there are instances that you can actually work out. People want to hold that data, and there's a lot of work that is being done to make sure that these models are in-premise, and they serve the purpose for that enterprise or for that organization. The third problem is people don't want to hallucinate, right? So there's a large problem of hallucination in Gen AI. How can hallucination be sorted out? How can model drifts be actually taken care of? Those are other things in which these models are looking at. So there are three body problems that you look at is what would be that LLM or SLM, whatever you might want to build in, SLM being a small language model, which serves your purpose. So you wouldn't use a sword when a pin could actually work out in certain cases. What kind of infrastructure stack would you apply? Whether it's going to be NVIDIA, whether it's going to be AMD, whether it's going to be on Intel. So that's a decision that you have to take from an OEM perspective. And then the third is obviously the governance. And governance, whether it comes from people like Watson X, you build it on your own, or you actually get it from NVIDIA, which is the NeMo guardrails. We've worked with NeMo guardrails, and they serve a fantastic purpose. And these guardrails are brilliantly amazing in terms of what they do. They can actually stop models from actually hallucinating to a certain extent, but also supply back with the right answer. So for example, if I'm building a model about India, and I ask a question saying, who's the Prime Minister of Indonesia, even though the model gets the answer behind the scenes, it will not put it if the guardrails have been told to only talk about India. So these guardrails are those governance facets that we actually look at over there. The left-hand side is obviously RAG. And for those who know RAG, this is retrieval augmented generator-based implementations. You want to control hallucination in your company, enterprise, and organization. You make sure that you place those documents so that the answers come from those documents itself, rather than the model drifting and talking about open source as well. And of course, the work that you do as AI engineers or AI developers is largely about fine tuning, making sure that the model is compressed using LoRa and QLoRa techniques, and you actually look at the data ingestion facet in terms of how the model does. The other part that is happening is the agentic workflow. So large part of chains and agents and retrieval strategies are now taking these models into downstream tasks with our service management, ops and care, and so on and so forth. The other part that you see over here, region.ai, is something what Tech Mahindra is also building, because fine-tuning a model also requires you to look at annotation in a different way, making sure that the model is also answering the right response. You can annotate that response and give it back into the model to make sure that the reward modeling of the model is done better. It has got a good amount of reinforcement learning that is placed in. So that's another system that we have actually now built across our model, saying no longer have to pick up pieces, look at things, and then go over there. You've got an easy user interface which can go through all sorts of model management, like an MLOps structure, which can give you ranking, which can give you annotation, which can give you all sorts of workflows which you want to maintain for your models as well. Question is, what's next? Everybody's talking about LLM. That's gonna be the story for this year and the next. However, there are agents which are actually now coming in. For those of you who obviously know, a large part of the guardrails that actually run behind this are also reflection agents. These agents are working pretty well in terms of two AI systems combining to each other, and they're talking to each other in terms of making things better. For example, if one of the agent is given a task to write a code, the other agent is also looking at how the code is written. So the two continuously talk to each other to make sure that the code written is correct, is as per syntax, is also not exposing anything in terms of security facets as well. And it's been found out that if you use some of these reflection agents, the code pieces that you generate are 65% more accurate than if you use a single agent or a single AI system to actually do that, like a ChatGPT. There are some other facets of agents which are coming in, like tool use and planning, but there's a large amount of research that is happening on the multi-agent collaboration part, where, while multi-agents tend to work sometimes pretty well, if they work, if they don't work, they don't really work well in terms of the agents as well. So that's why multi-agent collaboration. But my research and my team's research also goes a little bit beyond. I think you would have heard about stories from single bit LLMs that Microsoft has produced, and also how do you produce SLM. So we are, working very hard to figure out whether single bit LLMs really work well, and where is the balance of single bit LLM in terms of language and also multi-mode structures, so that we can see that a size of the model, a particular facet of model for, let's say, a use case works well in single bit, or does it work well for all cases as well? So that's a kind of research that we are actually looking at for single bit LLMs. There's also another technique which is also quantum inspired, which also comes from tensor networks. And tensor networks normally are used in multi-body physics, but these tensor networks are now being used to reduce the size of the tensors that the neural network really uses, and tries to pick it together and bring it down and crunch it in terms of how do you condense the neural networks. The biggest use case, if you want to see about tensor networks, is Monte Carlo search. In order to train or to get Monte Carlo search, you sometimes take a lot of time. That time gets reduced by almost about 1 by 100,000 or 200,000 or 20,000 in terms of how that reduction happens, keeping the same precision of the search as well. So this is another philosophy which a lot of people are now using. Me and my team are researching on, and since I have been researching on language for the last 20 odd years, the culmination is how do you make language similar to human brain? And sorry, all that you do today while you're listening to me, you may be thinking about certain other things, you may be writing, you may be talking to somebody. All that parallel activity happens through God-given supercomputer in your neocortex, um, which takes about 40 watts of power in doing this, right? If this was AI, this would have taken about 40 kilowatts of power to do that. How does the brain really do that? The brain has certain ways in which it actually looks at information coming in, and mostly it's about electrical impulses that carry forward between two neurons. If you go back to old biological sectors, these neurons have connections which are called synapses. And synapses have been trained earlier by somebody called Hebb or John Hebb, who said that Hebbian plasticity comes within these synapses. So what does Hebbian plasticity really mean is, if you come from, let's say, an alien world, and I suddenly plant you into a forest, you hear a tiger roar, you would not do anything because you don't know what a tiger really does. But if you see the tiger mauling, let's say, another animal, you would suddenly run away. Now, second day, I place you again in that forest, and the tiger roars again, you would run because your synapse has taken a short-term memory saying that you knew what the tiger would do, and this would be harmful for me, and I have to run away. So what has happened is that the weight between two neurons, where a neuron A was firing neuron B, has suddenly increased in terms of the synaptic weight. And that has actually given you short-term memory. If you continue to do this, you actually develop a long-term memory which goes back into your hippocampus and gets stored in terms of a register, which becomes a long-term memory. That's why you say that if you know how to ride a bicycle, you will know this for all your life, because that's actually kind of a plastic memory that has gone in behind into your hippocampus. We have done, or we're planning to do, and we have done one part of it, trying to take that structure of human brain into AI. And this AI is so closer to human beings and human references. And the main reason for it, it doesn't carry any neural network. It doesn't carry any differentiation. It doesn't carry any backward propagation or a forward propagation that the neural network does. And it does its work just like an electrical signal will travel between two neurons. And we have seen great results in terms of arrow of causative language, which is the natural language generation that we do. The second thing that this system does, which is very well, and we have found out, is that it unlearns as well. No AI unlearns on its own, right? The AI only learns. Unlearning facet has to be brought in. The temporal facet of AI has to be brought in. Temporality has been done using recurrent neural networks or certain others. But by definition, neural networks themselves are not temporal. They don't look at time. Whereas this one does. If the synapse between two neurons doesn't get hit on a pathway, the synapse reduces itself and the synaptic weight reduces. So it's kind of a forgetfulness that the AI forgets over a period of time. I have got a paper written. I can send it across to all of you in terms of understanding. But this is also, and all of this is happening within your PC, right? This is CPU that is doing it. There's no need for GPUs, so there's less compute. There's obviously memory required, but memory is cheap. But there's also less carbon because you're actually trying to do it with lesser amount of data in terms of what we're doing. So this is some of our research that we're doing. And then we also do a lot of quantum work. The top one is something that we're doing with some of the aircraft industries, where we're trying to use quantum generation networks to generate imagery when the pilot wants to land in stormy conditions, which is so difficult for pilots these days, and with weather changing abruptly and all sorts of things happening with the drops and jet streams, or the CAT, they are called clear air turbulences that is happening. There is so much of work that can be done on quantum. There's also a lot of work that we're doing on quantum resilience. While quantum key distribution and quantum security works well, there's a good amount of measure or research happening in terms of how do you make data at motion being more resistant in terms of the cybersecurity practices as well. Our ecosystem is unique. We connect to almost all governments. We connect to universities, as I told you. These are some examples. I am an advisor also in the Atal Incubation Center. We keep connecting to students who are doing some fantastic work. The entire innovation ecosystem of Bangladesh is run by Makers Lab. This is at the behest of the Prime Minister that came to us, and we have now created 10 startups in Bangladesh who are actually working for the government. We also train Omani governments and Omani government officials largely on AI, on IoT and startups, etc. And we are also good partners with Australian government as Australia. They take our consultancy in terms of if a industry wants to set up a kind of startup base over here. So I'd leave it there, but I'll and open up for questions. I am happy to share this. I think it's not just about Indus that we look at in terms of what we're doing. Indus has come in as a part and parcel of a large collaboration and system that we have actually done over the last 10, 12 odd years. So open for questions, if any, Alok. Please go ahead.
Great. Thanks, Nikhil. Very interesting and very insightful. And I'm sure people will have a lot of questions. So anybody who has a question can unmute themselves, maybe switch on their camera and ask a question. I think there are 3 in the chat, so maybe Nikhil, you can take those up first.
Yeah, others question was by speech data, you mean audio recordings? Yes, a lot of audio recordings happen because I think I'll tell you others, the problem over here is if you go to typical Marwadi and I give you a English statement saying last week I saw a film, your Hindi statement would be पिछले हफ्ते मैंने एक picture देखी. If you go into Marwadi, typical Marwadi, the answer is लारला हफ्ते मैंने एक film देखी. Now that larla word as a token doesn't exist, so you had to capture it into speech and then go into kind of text-based system.
Nikhil, thank you for clarifying that. And I have a follow-up question now.
Yeah,
typically, when we speak, especially in casual conversations, we don't really stick to one language, right?
Yeah.
Regardless of the dialect, if I'm speaking Hindi, I can always put in some English words.
Correct.
So how do we handle that situation?
So no, we were very particular. Others, we said, "अपनी भाषा में बात करो, boss." और ये sentence है, इसको अपनी भाषा में दो. So the question was not to jumble these words together. What we found, others, is that if you jumble these words, right, the hallucination typically increases within the language as well because the words get picked up in terms of probabilities for a generative system. So we were very particular when somebody wanted to speak, said, "Boss, please, अंग्रेजी मत बोलना.
Okay.
हिंदी का ये sentence है, इसको अपनी भाषा में बोलना.
Okay.
जो बनाना बना के बोलो उसको, right? Something like that.
Second question that I have is that when we are interpreting the speech, the meaning of certain words can differ from region.
Yes.
Right? How do we handle that?
Yeah, so we handled it by having people close to them when they were speaking. And if there was a word, let's say larla, typically Indian ASR system would take it as ladla.
Okay.
So we actually made sure that the word was changed internally, right? It meant larla, not ladla, right? So
okay.
that was how the token was generated by us.
Okay.
So a bit of an annotation work that we did when we were looking at it.
All right. Thank you. Thank you so much.
No worries.
So next question is from Gopal. Speak about how the costs were so low.
Yeah, so I was helped, Gopal, right, by the government. So basically, for example, if I had done this on typical clouds like an AWS or a Microsoft, this would have costed me huge amounts of money because they charge you by the dollar and they charge you by the hour. Obviously, CDAC has been great partners in actually doing this, number one. So we got subsidized rates from CDAC in terms of using their GPUs, which largely got the cost down. Also, a lot of cost was borne by some of we are an investment as in Makers Lab and R&D, and we actually know how to actually lower down that investment. But largely, if you look at from a training perspective, our cost went down because the GPU cost or the cost of using per GPU per unit was lowered by this. And for that, I'm very thankful to CDAC, CDAC Pune for doing that for us.
Thanks, Nikhil.
Great. Shashank had a question. Why are you patenting and not open sourcing?
I'm not patenting. I've open sourced it. This is not a patent. It's open source on Hugging Face. You can take the model and you can do this. Look, it's a single shot fine-tuned model, which I opened it to the Indian community right away. I have not patented anything.
So Shashank, maybe your information is wrong.
So Shashank, my patent is on something else on the AI. The patent pending part is on the brain research that we are doing, Shashank, and not on Indus model. Indus model is completely open, was meant to be open for Indian innovators and community. You can still download this model from Hugging Face. It's open, it's free. Go on to Hugging Face and search for Project Indus. You can download, use it. It's a single shot fine tune, so you'll find some variations over there, but it's up to you to now take that model, fine tune it, reward tune it, use it in the way that you want to do. It's got dialects. You may add dialects and so on and so forth. So.
Okay, question from Shailesh. Would love to know more on the guardrails being used. How can I understand more about
So Indus had its already own guardrails being built in Shailesh, but we actually, when we built the model for Garuda, obviously because NVIDIA was there, we used the NeMo guardrails. And NeMo guardrails are a great system. If you look at the NeMo stack of NVIDIA, the NVIDIA NeMo stack takes care of not just the data curation, etc., and parts, but also carry through with terms of creating the model and a guardrail attached to it. Their guardrails have good amount of ruling systems that are based over there, both expert systems, but also the kind of AI in which the guardrail uses. Those guardrails are very good. For Indus, typically, we actually made sure that the guardrails had some connotational values of information that we place in, right? So, for example, we made sure that this will not happen, this will not happen. You will not ask a question, bomb kaise banate hain? You will not ask a question, Atmatya kaise karu? Sort of that story. So this was largely annotated with Indus. But guardrails of NVIDIA work pretty well in terms of NeMo, and IBM Watson X guardrails also work very well.
Okay, thank you.
Next question by Sheetal. Is it trained on all Indian regional languages? Like
only
Marathi
Hindi and dialects. Only Hindi and its dialects. We plan to do it for all languages. Remember, there are 19,200 unofficial dialects. When we come to Marathi, Marathi itself has about 16 to 20 different ways in which Marathi is spoken, which is things that we are trying to do later down the line.
Okay, question by Sarita. You have built very frugally. How about cost for users? Have you thought of innovations on that front, particularly
no cost
on individual?
You have an open source system. You can use it.
Okay, Shailesh has a follow-up. How are you handling scripts, e.g. English, for example? I
Yeah,
think
so
you're doing only Hindi.
Yeah,
right?
we're doing only Hindi, but if you write a English script, we actually translate it back into Hindi and we do it. And that's kind of a transcription that we do.
Great. Any other questions or comments people have?
I think it was a very illuminating session, Nikhil. Very well presented and very comprehensive. Thank you very much.
Thank you. Thank you.
Great. With that, we will close the session. Thank you, everyone, for attending. And thank you very much, Nikhil.
With one question somebody has asked about Garuda.
Okay. What is that question? Sorry.
Is it government
Garuda, is it government backed?
No, it's not government. It's actually a combination between us, NVIDIA, and our partner, which is a telco. But we are doing the first use case for government. So in a certain way, yes, government's looking towards it to actually serve the purpose for the citizens. But it's not really government backed.
Just on that, Nikhil, since that's also Bahasi, again, no tokens were available there, or how? So can you just tell us how this token, like a dialect, just tell us a little bit about how you generate token and what exactly goes into it. We lost Nikhil?
I think we lost Nikhil. Let's just wait a second.
So I'm a part of Nikhil's team. Can I know what is the question? This is Kanchan here.
Yeah, Kanchan, on Bahasi, right? The Garuda thing is a language.
Yes, that's the language, Bahasa.
Bahasa, sorry. So again, the tokens there were, I'm guessing, not available, right? So is that
right? So there also the way it works was we kind of collected a lot of data and then tokenized it. Yeah. So similarly, it was done like in case of Indus. In case of Bahasa, we had it a little bit better because a lot of Bahasa data, digitized data of Bahasa language was available online as open source. So we could reuse some part of it. And when we say, I think there was also a question about tokenization, right? How we do exactly?
Yeah. What exactly? You can elaborate on that, yes.
So what happens is, computers understand the language of numbers, right? So what happens is each of those words gets converted into numbers, and that process is called tokenization. I mean, I'm telling it in very, very simplistic terms. And if you consider, say, a word "kyun" and another word "kyunki," right? So, or any other word which has some prefix, suffix, which changes the meaning but not entirely. So what happens is every word when it comes to the tokenizer, it breaks it down into parts that it recognizes from its vocabulary, and then accordingly it tokenizes them. The tokenization is the first step when we start the process of training a given model.
Got it.
I hope that clarifies.
Yeah, that is helpful. Thanks. And these token, once you create the token, now it is available for everyone, right? So that's the
tokens are then used to train the model. In the model, you are training the weights, right? And then that weights model file that contains the weights, that is what you reuse to then fine tune for your own use case. For example, now we have got Indus, which is a single shot fine tune model. What it means is if you just compare it with a child, just a simple model is like child has started making complete sentences. Now, when you fine tune it, single shot fine tune means now it has understood that if there is a question, I have to give an answer. You can fine tune it for summarization. You can do multiple different things. You can take a use case. Suppose you want to make an agriculture related LLM. You can download Indus from Hugging Face. You gather data related to agriculture. You then fine tune it, and you can use it as a part of your application for, say, the farmers of India. So all of that is possible, and that is the reason why we open sourced this model, Project Indus, so that it can be used by anyone and everyone within India, so that we can reach the masses who speak all of these dialects.
great. Thank you.
Great, thanks.
There is one more question. I don't know, Kanchan, if you will be able to answer that.
Sure.
Customer engagement companies in the contact center space are innovating with GPT and Llama, etc. Are you planning to tie up with them?
Yeah. So the thing is that, see, we are anyway doing all of this, whether using GPT Llama or using Indus. We are open to use any model, every model that is available. And specifically for Project Indus, we have not retained the kind of monopoly of having this model ourselves. So not only us, anyone in India can use that model and then liaise with all of these companies and try to make solutions. Of course, since we have made it, certainly people will be coming back to us with issues or whenever they need support. Large enterprises would typically ask for support from someone who knows what the model does. So from that perspective, certainly we will have some skin in the game. But while we are also doing it, we would urge the Indian community to also take it up and then use it in different scenarios wherever they see any opportunity.
So, Kanchan, will it be possible to download the model and then train it on another language? So, for example, a language which is not covered currently, it's only in Hindi. Can I do it in Tamil?
You could potentially do it, but it may not work well. Yeah. Okay. So there are multilingual models, right? Even this one that we say, Hindi and its dialect. See, if you look at Llamas of the world or even ChatGPTs of the world, they are also doing Hindi. But you look at the quality of Hindi they are doing, right? It's not really coming out. Many times it kind of just misunderstands the question also. So we potentially could, but I would say that the family of languages, if you retain it, that is better.
Okay.
Yeah. All right.
I think if they share the same family, it might be easy to retrain for another language.
Yeah, dialects is what they're talking.
Hindi and Tamil are different families.
Correct.
Great. I think that was a fantastic session. Nikhil unfortunately dropped off. His internet had a problem. But thank you everyone for joining in. And Kanchan, please thank Nikhil on our behalf.
Absolutely, sure.
And congratulations to your entire team for developing this project.
Surely. Thank you so much. Thank you for the opportunity. Thank you.